Welcome to u-substitution, by the way. We've made it past the introduction to integrals. Now we are going to start applying these integrals, but when we have more complex integrals, basically, right? So now, if we are given these very complex integrals, like let's say, for example, like this one, and this one looks very, very interesting. Can you see the exponent even has an exponent? Like, how on earth are we going to do that simply just by integrating normally? Now, this is where we introduce our polynomial substitution, also known as our u-substitution, right? So in this case over here, these are all the 5 questions that we are going to be doing one by one. So I will have timestamps so that you can look at the respective numbers, meaning example 1 is this one over here, example 3 will obviously be this one, and example 5 will be this one, if you get the point. So I'm going to start with the first one as some type of introduction to u-substitution, and every single example will get more difficult and difficult as we go. So stay tuned, and yeah, let's just move on to the first one. Okay, so from our introduction, we know that this dx is in a weird spot. So let's just bring this dx down. So we're going to write it like this. So it's going to be the integral of 1 divided by 2x plus 3 with respect to x. So there we go. We made it a little bit more simple. But now we have a denominator with 2 terms, right? And now, over here, this would be a little bit crazy. If you were to do it like a normal integration, it wouldn't really be so good, hey? It's a little bit more complicated. So this is where we actually introduce ourselves to the u-substitution. So what we are going to do is we are going to let u equal to what is the root of our problem. This is the root of our problem. It's very, very complex. We have 2 terms in the denominator. So which means we're going to let u equal to that specific thing. So the u is equal to 2x plus 3, right? And now what we are going to be doing, so our steps goes as follows. We first let u equal to the complex part of our problem, and then we take the derivative, du by dx, right? Because u is obviously the subject of the formula, which is represented here, and then x is what it's in terms of. It has respect to x, basically. What is the derivative of this whole thing? The derivative of 2x is just equal to 2. Derivative of positive 3 is just equal to 0. So it's just going to be 2. Now, what we are going to do is we are going to make du the subject of the formula, because what I'm going to explain to you why this is important, right? So what we're going to do is we're going to take this dx to the other side as multiplied by dx. So it's going to be 2 times dx, like this, right? Our differential equations. Now that we have done that, can you see that we have du is equal to 2 times dx? Okay, but what do we note over here? So if we were to, okay, so what I want to first do is I want to get dx, right? I want to replace dx, and the reason why we're replacing dx is because if we substitute, so let me just substitute now. If we have the integral of 1 over, remember u is equal to 2x plus 3, so this will just be equal to u, right? With respect to dx. Now I'm going to show you why this is incorrect. Because we have the integral of 1 over u with respect to x, right? And this wouldn't make sense because obviously we're doing it with the variable u and not x. So what we are going to do is we are going to try and make dx the subject of the formula. And in order for us to do that, we need to divide both sides by 2. So that these can cancel, and then dx is just going to be equal to du divided by 2. Okay. Great. Now, what do we have here? So, I also recommend, whenever you have a constant, I recommend writing it as like whatever fraction or whole number it is, and then du next to it. So, which means we can write this as a half times du as well. And now, over here, what we are going to have is the integral of, so what is dx equal to? Dx is equal to half du. So, it's going to be 1 over u times a half du. Hey, can you see we've made some progress? Okay, so because this half is a constant, we can actually just take it outside of the integral. So it's going to look like this. It's going to be a half integral of 1 over u with respect to du. There we go. Now we can integrate with respect to u. And now from here, we just put a half outside here, square bracket, and then we are going to have the integral of 1 over u. The integral of 1 over u is just going to be equal to ln of absolute value of x. I mean, u, sorry. Whoa, almost made that mistake there. Plus c, because it's an indefinite integral. So that's what we're going to have, right? It's the natural log of absolute value of u, and then we are going to have the closed bracket plus c. Plus c has to go at the end, okay? Because it's an indefinite, once again. So therefore, the answer is actually just going to be a half, well, not the answer yet, I'm going to show you why. Half ln absolute value of u plus c. Now, this is where some students might actually just leave the answer like this, right? You can't leave it like this because we have u, okay? So we have u over here, and we need to actually replace u with x. Well, I mean, with what we had in terms of x, right? U is equal to 2x plus 3. So let's do that. So it's going to be equal to 1 over 2 natural log of 2x plus 3 plus c. And that is our answer. Because remember, our beginning started with respect to x, right? And we need it in terms of x at the end. Because it's an indefinite. And now you're going to learn, so basically this is the final answer, by the way. Now you're going to learn when we have definite integrals, there's going to be a little bit something different. So it's not going to be as simple as this one, but it's actually not really that bad. So that was the first example. Let's just move to the next one. And if you're still lost, I do recommend just keep watching. Otherwise, you can rewind. But yeah, just keep watching. You'll see how there will be a flow to all of this. Okay. All right. So here's number 2. We have the integral where the lower limit is 0 and the upper limit is the root of pi over 2. And we have the integrand, which is theta multiplied by cosine of theta square with respect to theta. Okay. Now that's a lot to take in right now. I know this is a huge jump from the last example. The last example was supposed to be a nice little easy one because obviously it is a little bit of a complex integral, but once again, using u-substitution makes our life so much easier. Now, this is where you actually need to use your own head. And unfortunately, as a university student or college student, this is what you need to do. You can't be spoon-fed anymore, and you need to know what you are going to do. Like, you need to know what you're going to be doing in the future here in this question. That's what I'm trying to say, right? So I'm going to show you why. Now, first of all, we need to take the most complex part about all of this, and we need to let it equal to u. Now, what I'm seeing over here is that we do know, we can actually say what is the integral of cosine of the angle, right? But we have theta square. Now that makes it a little bit more tricky for us. So what we are going to do is we're going to try and make it a little bit more simple. A lot more simple, actually. We're going to let u equal to theta square. Now the reason why I'm doing this is because we also need to get rid of this theta, so that we can have u as what we are going to integrate, right? So I'm going to show you why we do like this. So u is equal to theta square, and then our next step is to take the derivative on both sides, implicit differentiation, du by d theta, which is equal to 2 theta. That is the derivative of that. And then we need to make du the subject of the formula, so we're going to do that quickly, right? So this is going to be 2 theta multiplied by d theta. Okay. Now, what we notice over here is that now we have du is equal to 2 theta multiplied by d theta, sorry. Now what I want to do is I just want to write this down quickly. This is going to be the integral of root pi over 2 and 0. And this is going to be, and I want to actually, because this theta is multiplying by cosine, I want to take it to the end and show you what we are going to do now. We need to manipulate this. So it's going to be cosine of theta square multiplied by theta with respect to theta. Can you see now that we have something similar over here, right? But this 2 is in the way. So what we are going to do is we're going to divide both sides by 2. And remember what I said? You can actually just take this 2 as a constant over when you're taking a 2 over to the other side when it's multiplying, you're going to take it over as a fraction, 1 over 2. If you're not used to this immediate takeover, I do recommend then you can just use your method where you say du divided by 2. Remember, when you're dividing both sides by 2, you can write it like this, but you can also write it like this, multiplied by du. And now we have theta multiplied by du on its own. I mean d theta on its own. That means we can replace this with this. So now we do this. But we have a definite integral. This is where it gets a little bit tricky, because now we need to change our upper and lower limits. So how are we going to do that? Now, what we need to do is the following, right? With indefinite integrals, you need to actually change the upper and lower limits, but when it comes to indefinite integrals, then you don't really have to focus on that. So this is the only extra step that you have to take when it comes to definite integrals, which is not really that bad. So how we do this is the following, right? So now we have remember that x was equal to all of this, right? This is the upper limit and lower limit of x. Oh, no, sorry, it's not x, it's theta, right? But now, remember, we have it in terms of u now. So which means where this theta is actually represented as the theta lower limit, and this is the theta upper limit. Note my use of subscripts. I think some lecturers also use 1 and 2, but I normally use the letters L and U so that so that I can know it's the upper and lower limit. So which means now we're going to work with u upper limit and u lower limit now instead of theta. And how do we find this? Well, we're just going to take what we have u equal to. U is equal to theta squared, right? And the upper limit, we're just going to substitute the upper limit theta, which is root pi over 2. So this is what it's going to look like. It's going to be root pi divided by 2 raised to the power of 2, because the exponent 2 is over here. That's basically what we're doing. We're just substituting the original theta to give us our new upper limit and lower limit in terms of u. And this is going to be equal to, we can also write this as square root, sorry, this is actually pi. This can also be written like this as well. And then this is just going to be equal to, these can cancel here. This is going to be pi over 4. 2 squared is 4. So now we have our new upper limit, which is going to be pi over 4. So it's going to look like this, right? Also, oh no, let me not rush anything quickly. Let's just do our lower limit quickly. Okay, so now we're going to substitute our old lower limit for theta, which is 0. And this is 0 squared, which is equal to 0. So this is our new upper limit, and this is our new lower limit. That is how we find our upper and lower limit for our new u, basically. Okay, so now what are we doing here? We have the integral of, it's going to be pi over 4 and 0, our new upper and lower limits. Okay, now what do we note over here? Let's go back to our original one here. Theta, well, why did it not change the color? Theta multiplied by d theta is equal to a half du. So we're just going to substitute for that. It's going to be cosine of, and remember, our theta squared is just equal to u. So it's going to be cosine of u multiplied by a half du. There we go. Hey, we made a lot more progress now. Now, obviously, we have a constant over here being multiplied, so we're going to take that constant to the front. So it's going to be a half multiplied by the integral of cosine of u with respect to du. This is pi over 4 was the upper limit, and this is 0 as the lower limit. Can you see now it actually looks very solvable now? Okay, so we have a half. Now we can start to integrate. So the integral of cosine u is just going to be equal to positive sine of u. This is stuff that we need to know by now. And over here, we have the upper limit, which is going to be pi over 4, and we have the lower limit, which is 0. And now what we're going to be doing is we are going to do the same thing that we do with definite integrals. We're going to say it's going to be the f b minus the f a. So that's basically what we're going to be doing. It's the f of the upper limit minus the f of the lower limit. So it's going to be half multiplied by the sine of the upper limit, which is pi over 4. Okay. And then we have minus sine of the lower limit, which is 0. And there we go. Now that we have that, we can simplify further. And then what we note over here is this is going to be 1 over 2 into sine of pi over 4. If we look at our special triangles, we have the pi over 4 special triangle here, pi over 4. And this is going to be 1, 1, and root 2. So sine of that, it's basically, let's just choose this one here. It's the opposite over the hypotenuse, which is 1 over root 2. So it's 1 over root 2 minus sine of 0 is just equal to 0, according to our graph, our sine graph, because it's at the origin. And this is equal to, so we can just write this as a half multiplied by 1 over root 2, which is just going to be, give us an answer of 1 divided by 2 root 2. And that is our answer for this definite integral. Okay, that was a little bit of a more tricky one, but I promise you that it will get easier if you do practice a lot more with these types of questions. I'll see what I can still do with more of these types of questions, but I want to focus on getting all of the explanations down, especially with the trigonometric substitutions and all of that stuff, because I feel like it would be good to go over those as well. I just want to go over all these fundamentals before we get to the more challenging questions, which I'm not going to be doing in this video, but other videos in the future. Okay, so let's move on to the next question. Okay, now with this one, I think there's no surprise to see which one is making this a little bit more difficult, or a lot more difficult. It's the exponent within the exponent. So it's pretty much obvious what we're going to be letting u equal to. So let's just go through that right now. Okay, so over here, what we're going to be doing is we are going to be doing, oh, sorry, my fault. Okay, so what we have to do is we are going to let u equal to t squared, because we want to get rid of this little complex exponent here. Okay, so if we do that, we can actually take the derivative of this implicit differentiation with respect to t, and then this is going to be equal to 2t. And then we make du the subject of the formula. The dt goes to the other side, and it's multiplied by dt. Okay. And now, once again, just for the confusion to go away, we just separate, we take the constant over towards du, to the other side. So which means when we're multiplying by 2, we're going to divide by 2. Or you can multiply by a half on the other side. Okay. So also I should have just done like this. So it's going to be half du is equal to t multiplied by dt. Okay, cool. Now what do we notice over here? Now I want to just show you something quickly, is that what we have over here is it's going to be the integral. I want to just change this a little bit here, and this is going to be 0, and then I want to write this like this. So it's negative t squared like that, multiplied by t by dt, or multiplied by dt. And that is exactly what we have here. So we can just replace that with this, and we can replace this t squared with u, which is exactly what we decided to make. Okay, but now before we move on, we have a definite integral. So which means we need to make our extra step over here. We need to do our extra step. So this is how we're going to do it. Note that u is equal to t squared, meaning in order to find our upper u limit and lower u limit, we just need to substitute the upper and lower limits of the original, which was t is equal to infinity and t is equal to 0. So the upper limit we're gonna say infinity squared, and then the lower limit is going to be 0 squared, and infinity squared is just going to be equal to infinity, and 0 to the power of 2 is just equal to 0. So it's basically the same thing that we had. Okay, so that's our new integrals over here. That's going to be there. Infinity is the upper limit and 0 is the lower limit. Okay, so we're just changing things around over here. So we have e raised to the power of negative u. Now remember that this t squared is equal to u, and we just have the negative in front of it, and then t multiplied by dt, which is here, is replaced with a half multiplied by du, where we can take the half out to the other side, to the outside of the integral, and then therefore it will look like this. It'll be a half integral infinity as upper limit, 0 as lower limit, and then we're going to have e to the negative u, or we can actually write e to the negative u as 1 over e to the u with respect to du. Hey, there we go. We made some progress. Now we're going to be using another law that we're supposed to know for integrals. It's going to look like this, right? So I'm going to do it in a different color here. And for us to do this, we are going to do the following. Oh, my bad. I completely messed that one up. This is actually supposed to be e to the negative u. And the reason why we're actually keeping it like that is because let's just consider the following, right? If we're saying the integral of e raised to the power of negative ax, or sorry, just ax, this is our property with respect to x, for example, this will just give us the answer of, it'll be e raised to the power of ax, so it's going to be ax divided by a, okay, plus c. So that's what we have. So we need to do it in that same formation. What is our a value? So let's just write this down like this, right? Our x is just actually equal to u. Our a value is equal to negative 1. Do you note how this is negative u? So that's just also negative 1 times u. So hey, and then we have e over here. So that means we can just replace our values accordingly. So it's going to be equal to a half, and then our bracket. So we're going to take the integral of this with respect to u, and then it's going to be e multiplied by the a value, which is negative 1, multiplied by u, which is represented as our x, and then it's going to be divided by the a value, which is negative 1. Okay, and then our upper limit, which is infinity, and our lower limit, which is 0. Okay, now we have something like this. We can just make it look a little bit more simple, or we can actually simplify it a little bit further. So it's a half into, and this is going to be negative e to the negative u, because it's divided by negative 1. So we can just write it as negative 1 times e to the negative u. Upper limit is infinity, lower limit is 0. So then we can write it like this. It's going to be, now we just need to work with the inside here, right? This is our u, upper limit for u, and this is our lower limit for 0, or for u, sorry, which is equal to 0. So that's what we're going to be doing over here. We're going to be using, or we're just going to say that it's going to be a half multiplied by negative e to the power of negative, and this is going to be our upper limit, which is infinity, and this is going to be minus negative e raised to the power of negative 0, like that, and then we close our bracket like that. Okay, so that is what we wrote down over here. Now we just need to simplify things. It's going to be a half multiplied by, and we can actually write this as negative 1 divided by e to the power of positive infinity, because it's negative to positive exponents, and then this is going to be plus because the negative and a negative gives a positive, and this is going to be e to the power of negative 0, which can just literally be equal to 1 anyway, but let's just focus on this right now. It will be equal to 1, but let's just write it like this. It's going to be 1 divided by e to the power of 0, like this, which is just going to be 1 divided by 1. But let's just keep moving over here. Okay, this is going to be equal to a half multiplied by. Now, I want to just go into a little bit more detail over here with this one. Let's take into consideration, remember, this is our upper limit, right, that we substituted in. This is also known as, it's going to be the limit as u approaches infinity, that one, and then it was, whatever that, okay, so it's going to be of, we can take the negative out because that's basically just the constant, 1 divided by e raised to the power of u, right? So that's basically something that we have over here. Now this is going to be equal to, if we do the substitution, it'll be 1 divided by e to the positive infinity, which we know, this number is going to be so large in the denominator that it's going to approach 0, that it's just going to approximate to 0. Because remember, it's 1 divided by this huge denominator, which is going to approximate to 0. Remember that we're still working with the limits. It's our upper limit, meaning that this answer here will just be equal to 0. Okay, or negative 0 in our case over here. So I should have added there the negative because of this negative right over here, negative 0. So it's a negative, but it doesn't matter. But negative 0 plus e divided by e to the power of 0. E to the power of 0, anything to the power of 0 is just equal to 1. So it's 1 divided by 1, which is equal to 1. And now we can just write it like this. Negative 0 we don't have to consider. So it's going to be a half multiplied by 1, which is just equal to a half. And that's the answer for this definite integral with u-substitution. Now that one was a little bit of a tricky one. I feel like all of them are just tricky. I'm going to say that every single time. So let's just move on to the next one. Okay. This one. I think this one was a very nice one when I was doing it myself. So what we are going to be doing is the following, right? So first of all, we can clearly see which one is the most complicated part of our integrand. It's definitely the square root of theta. So what we are going to do over here is we're going to let u equal to root theta. Okay. Now we need to differentiate. So before we do that, we turn this into a power or an exponent. So it's theta raised to the power of a half. And now that we differentiate, it's du by d theta. And this is just going to be equal to a half multiplied by theta raised to the power of negative a half. And then we just make du the subject of the formula. And then this is just going to be a half multiplied by theta raised to the power of negative a half multiplied by d theta. Okay. Cool. Now that we've done that, let's just quickly take the constant over to the other side. So it's going to be written as 2 multiplied by du. And then we're going to have, and then we are going to have this theta raised to the power of negative a half, which can also be written as 1 over root theta. Okay, with respect to d theta. Okay, so what are we going to do with this integrand so that we can make these the same thing? So I'm actually going to rewrite this like this, right? So it's going to be the integral of pi square over 4 and 0 over here. And then we can actually write the sine of root theta like this, multiplied by 1 divided by root theta with respect to d theta. Now you can see that this is exactly the same as that over there. So now we're just going to substitute 2d du into that one over there. Okay. So that makes our lives a little bit easier. So now that we can do that, we can do the u-substitution properly. But remember, before we do that, we need to find a new upper and lower limit, because remember, we have u now, a new variable. We've assigned a new variable, and it's a definite integral. So this is how we're going to do it. The upper limit of u and the lower limit of u, we're going to do as the following, right? So what is u equal to? U is equal to root theta. So we're just going to substitute our upper limit of theta, which is pi square over 4. So it looks like this. So it's going to be, it's going to be like this. And it's pi square over 4, which is just going to be equal to, we can write it as root pi square divided by root 4, which is just going to be equal to, these cancel, it's going to be pi on the top, and then square root of 4 is equal to 2. And then also the square root of the lower limit, which is 0. So therefore the square root of the lower limit is just equal to 0. So that's our integral over there. And I'm sure that by now we know that whenever we have a constant in front of the du, we can automatically just write it right at the end of the integral, right behind the integral. So we can write the 2 over here before the integral. And then we have our new limits, which is new upper and lower limits, which is pi over 2 and 0. Okay, great stuff. And now that we've done that, we just substitute accordingly. Sine of root theta is equal to u, which we have assigned, multiplied by, or with respect to, 1 over root theta by d theta, or sorry, multiplied by d theta is equal to 2 du. So that's just, or just, yeah, so we already have our 2 over here, so we're just going to write du over here. Now we can integrate properly. So this is how we're going to integrate. It's going to be equal to 2 multiplied by our bracket over here. The integral of sine u is just going to be equal to negative cosine of u. And then our upper limit is going to be pi over 2, and then our lower limit is equal to 0, which we've just assigned over here. Right? and then we're going to have 2 multiplied by. Now we're just going to take the upper limit and lower limit in, but we're going to subtract them by each other respectively. Okay, so it's going to be minus cosine of pi over 2 minus, and then this is going to be negative cosine of 0, like that. And now we just need to go further here. 2 multiplied by negative cosine of pi over 2 is just equal to 0, and then minus, or this is actually going to be plus because the negative and the negative gives a positive. This is plus cosine of 0, which is equal to 1. Therefore, we can disregard this negative 0, and therefore 2 multiplied by 1 is just equal to 2. And that is our answer for this integral, this definite integral. You see, now that we're getting the hang of this, and we're actually understanding the process of u-substitution or polynomial substitution, it becomes easier actually. Now, I just want to quickly look at this quickly, right? We need to manipulate these integrals so that our u-substitution works. And that is up to you. When you are doing and the only way that you can get used to this is if you practice enough. Right now, I have definitely been practicing a lot, and I'm used to looking for these little hints over here within these integrals. So if you practice a lot more, then therefore you can actually be able to spot these tricks out in no time. Take the integral bees. I'm pretty sure you've seen maybe 1 or 2 of them, where these people do integration so quickly, but it's the very advanced ones, which is actually insane. So hopefully one day I'll probably take part in that, but I'm still learning my integrals here. Okay, and I'm just sharing my basics with you that I've known so far. Okay, so that is how we get this answer here. Let's move on to the final integral. Okay, now this one is the definition of tricky integrals for obviously beginners, right? So this is an indefinite integral, so it makes a little bit easier on the calculations. But now what we have to do, or now what we see, is we have a square root within a square root. Now that is probably the most intimidating part, but trust me, remember, we need to try and find what is the most intimidating one over here. Now, what we are going to do is we are going to take the inside of the main square root and let that equal to u, so that we can make it a little bit easier for ourselves. So we're going to say that u is going to be equal to 1 minus root x, like that. Okay, nothing too crazy about that. Once again, I said what makes it very complex is definitely in the inside of that square root. Okay, now what we're going to be doing is we are going to say, we're going to take the derivative, but before we do that, let's just write this as a power. So it's 1 minus x raised to the power of a half. Now we can take the derivative on both sides, and then this is going to be du by dx, which is equal to, the derivative of 1 is just 0, and the derivative of negative x to the power of a half, this is just going to be equal to negative a half multiplied by x raised to the power of negative a half. Okay, and then we're just going to put dx on the other side. So it's going to be du is equal to negative a half x raised to the power of negative a half multiplied by dx. Okay, now, like I said, we always just have to take the constant over with du. So it's going to be equal to negative 2 multiplied by du. Okay. I'm just basically like taking shortcuts here. So I'm not showing all the processes. You should know how to take things over by now, because we are in college or university. And if you do struggle, you are cooked, brother. Okay. So now what we are left with is it's going to be x to the power of negative a half. Now, what we can actually write this as is the following, right? We can write this as 1 over, because we got rid of this constant, we can actually write this as 1 over square root of x over here, multiplied by dx. Okay, so now this is where it gets really tricky. Now, this is definitely the hardest out of the bunch. Now, this is why. Note that we have 1 over square root of x multiplied by dx, right? But where do we have a fraction in here? Now this is where it gets a little bit more manipulative, right? You have to manipulate really well here. Now let's do the following. What we are going to do is we are going to multiply both sides by square root of x, like this. So we're going to multiply both sides by square root of x, such that these will cancel. And then therefore, I'm just going to write dx on this side. Dx is equal to negative 2 root x multiplied by du. Okay. So now what we have is we have dx. Now, if you don't have a part where you can actually manipulate, well, like you don't have a fraction in this case, we're just going to find out what is dx, and then we're going to substitute, okay? So just bear with me right now, and you'll understand what I'm doing over here. Now that we know that dx is equal to negative 2 multiplied by root x times du, what makes this a little bit tricky is just the x over there, the root x. But let's just consider the following factor here, right? What we know over here on the top is this is going to be u is equal, we know that u is equal to 1 minus root x. But we want to replace root x so that we can get u only. Can't you see that we can actually just replace it by using this beginning equation here? Meaning that if we write down in terms of square root of x, so I'm going to rewrite it here, u is equal to 1 minus root x. So this is our second step over here. Write that properly. So this is our second step here. This is u is equal to 1 minus root x. So what we are going to do is we are going to take this root x on this side and then this u on the other side. Therefore root x, it's going to be positive root x is equal to 1 minus u. Can you see that now we have root of x, which is here? We can replace it with that, and we only have it in terms of u. How amazing, you see? That's how cool this is. So now we just need to substitute all of our variables. This is equal to, and what I'm going to do, note how we have negative 2 as the constant, so we're going to take the negative 2 out like this. And it's an indefinite integral. And root of 1 minus root x is just equal to u, so it's root u. And then our dx is equal to not negative 2, remember we took the constant out, it's going to be multiplied by root x. I'm just going to write this now here, just to show you the process, multiplied by du. Now remember when we said root x is equal to 1 minus u, so you're going to do that exactly. So it's going to be root u multiplied by root x is just going to be equal to 1 minus u with respect to du. Can you see now that we actually have this over here? So I'm going to try and see if I can just separate that. So now you can see that we only have u. So we're going to multiply this root u into both of these terms, and it's going to be equal to negative 2. Let me just write this a little bit compressed like this. It's going to be root u minus root u multiplied by u with respect to u. Okay, and then over here we can just write this. Remember, this is exponent laws over here, so we can write it like this. It's root u multiplied by u, where we can write this root u as u to the power of a half multiplied by u to the power of 1, which is equal to u to the power of 3 over 2, which is equal to root u to the power of 3. So there we go. Root u to the power of 3 is what we have, which is right over here. So we're just going to replace that. Negative 2 integral of root u minus root u to the power of 3 with respect to du. And now what we're going to be doing is we're going to take the integral into both of these terms here, like that. And then it will look like this. It'll be negative 2 and then bracket. And then I think actually what we should rather do is we should write this as exponents instead. So it's going to be u to the power of a half. Should have done that in the first place. And then minus u to the power of 3 over 2 with respect to du. Okay. And now we just need to take the integral of those two terms like that. Okay, no, bracket. So it's going to be u to the power of a half. The integral of that, or yeah, we can just write it as this. So it's going to be u to the power of a half plus 1, which is equal to 3 over 2, divided by 3 over 2. Okay, and this is minus, then we're going to have u to the power of 3 over 2 plus 1, which is 5 over 2, divided by 5 over 2, plus c at the end. Okay, and now we just need to simplify. We can tip and times this and this over here, which will actually look like this. It'll be negative 2 into, and then this will be 2 over 3 multiplied by u to the power of 3 over 2 minus, and this will be tipping and timesing this one over here, which is going to be 2 divided by 5 multiplied by u raised to the power of 5 over 2 plus c. And now we can actually just write this down like this. It's going to be equal to negative 2 bracket 2 over 3. And now we can just write this as our root, which is going to be root u to the power of 3 minus 2 over 5, which is multiplied by root u to the power of 5 plus c. And now remember from I actually forgot which one it was, but when we had to substitute the u in, remember we have to end our answer with x, right? We can't end our answer with u because originally it was with respect to x, and we need to find that integral with respect to x. But the u substitution obviously made it easier for us, so we just need to substitute we have to substitute whatever we made u equal to. U was equal to 1 minus root x, so we're just going to do that. This is equal to negative 2, and this is going to be 2 over 3 multiplied by, this is going to be 1 minus root x raised to the power of 3, like that, minus, this is 2 over 5, multiplied by the square root of, this is 1 minus root x raised to the power of 5, plus c. Okay, and then let's just take this negative 2 into the brackets, like this. This is going to be equal to negative 4 over 3 multiplied by the root of 1 minus root x raised to the power of 3 minus, and that's actually going to be a plus because negative and a negative gives a positive. This is going to be 4 over 5 multiplied by root of 1 minus root x raised to the power of 5 plus c. And that is our final answer for this integral. Obviously, if you want, I think some textbooks would normally write the positive first, but it really doesn't matter. And this is the answer for this last integral.